We are going to discuss this wonderful project done by one of our MDes students, Avinash Prabhune. We call it the window mounted solar oven. We all know that in the current SDGs, sustainability has become the key. And it's quite foolish that we have so much sunlight in the country, so much heat in the country, and we still are using, gas and petrol and kerosene for cooking purposes, which is quite ridiculous. So the cause for the project is that we want to use the solar energy for cooking. And then the challenge was how to find out why people don't use it, right? So Avinash went to various locations and he checked out, and we clearly see that it's not convenient to cook food in a solar oven because you have to keep it in the sun, you have to go out a number of times to see what's happening, and that inconvenience makes the solar oven very unpopular. We came up with this wonderful idea to cook from indoors. So the idea is to mount the solar cooker in the window of a house where you have sun, and mostly from a Vastu point of view, the kitchens are towards the southeast side, and you can have your window mounted over there. And in case it's not in the kitchen, it could at least be in the living room or in the dining hall areas where there is ample sun on the outside wall. So you can see how it's so convenient if it's inside. You are in the comfort of your house and your food is being cooked from the sun outside. So here we have mounted this solar oven in the studio. You can see one of our students actually getting hot rice from the solar cooker in the Design Innovation Center at the IDC IIT Bombay. Once we designed the window mounted solar oven, what became interesting is that people came and asked us, very few people have sun on their windows. So what will you do when there is no sun on the windows? And if they have a balcony, why not use it in the balcony? So that brought us to this, a window mounted oven which could be mounted on a stool, it can be mounted on a frame, and it also can be mounted on the grill of the railing. So we created all those mounts and we took this solar oven to various places. Now that is a very critical issue. In the 7 concerns of innovation, we come up with the most important concern, which is the context. A number of times we design products and we forget the context in which we are designing. We understand the user for sure. We know that this product is for the household to cook food, but we don't focus on the context of where exactly are they cooking, what are they cooking, will the sun be available all along. So for sure, right, this product can't be replacement of a gas stove, will it be? Manit, will it be a replacement of a gas stove? It can't be, because when there are clouds outside or when there's no sun, you can't cook at all, and that's not acceptable to any family. So very clearly in the context, we came up with this issue that it will be a fuel saving device in your house so that you can save and cut down the cost of fuel and electricity if you're using an induction cooker. So that is the whole premise of this project, that it is not a stand-alone cooking device. It's a device to actually reduce your power consumption. So Avinash, when he started his project, we were very intrigued. So we went and actually visited enthusiasts who actually cook on solar ovens very rigorously. Mr. Vipin Chitre has 2 solar cookers in his balcony. One is the parabolic solar cooker. It's very powerful because the parabola concentrates all the heat to the center where they keep the bowl for cooking. And he also has a box type solar cooker, which is the traditional solar cooker which he uses to cook dal and rice. And on the parabolic one, guess what he can cook? Any idea? You can bake stuff, it's very hot, and you can do roti. You put a tawa there, you can get roti. So he can really do all, because I told you they're very rigorous enthusiasts, so they will do all these things. This is the whole idea premise where Avinash first came up with this idea during our discussion. We said that, okay, to make it convenient, we will mount on windows of the people's houses, and that's how we looked at grills and windows in high-rise buildings, and we said, no, we will look at that. And then, as always, in the design methodology, you need to understand what all types of cookers are available in the market currently. And you'll be surprised that the Ministry of Non-Renewable Energy gives a huge discount for people to buy solar cookers. And after the discount, the solar oven, which is the box type solar oven, costs around 4,000 to 4,500 rupees. But still today, very, very few people buy it. And of course, there are different types of hobby cookers, like the panel cookers, and there are commercial cookers, which are like the parabolic cookers, which are there.
So what will be the cost of our solar cooker?
So our window mounted solar cooker, we are saying that should actually be much, much more high tech, much more user friendly, and should also cost less than the current the box type cooker, because that will make larger market, right? We are also addressing saving of gas, so we were actually targeting it at making it very, very cost effective. So here then we went and observed how people cook on these cookers, how there are NGOs who do training of people, rural folks, to use this cooker effectively, and all those promotions do happen from the MNRE, because even the government is very much interested in saving gas and other non-renewable energy. So here we have again the parabolic solar cooker. The parabolic solar cooker is slightly more expensive. It costs around 6,000 to 7,000, and it is very tedious to cook on this because you get some of the heat when you're using it. And I'm very happy to mention that one of my students from BDES first year did an internship, and then he designed this parabolic cooker in such a way that the cooking vessel is close to the body. All of you must have seen the Tata Sky dishes. The parabola is at an angle. So when the parabola is at an angle, you can have the cooking stove on the top, right? All your Tata Sky dishes have the dish here, and they have the antenna on the top, right? So now same thing the student did. He created a parabola here, and he created a ring to keep your vessel here, and he made tea. And this student in his first year internship itself did a working prototype. So that's the beauty of how we can make every product user friendly so that it can have much, much better impact. And see how, I was mentioning that when they're making roti, it's pretty hot and it's very difficult to use it. And there's a different type of cooker where there are panel mirrors which they're using. And of course, industrially, it is really popular. In fact, most of the kitchens in large hostels and in large spiritual organizations, they're using panels and energy from the parabolic mirrors quite effectively to both cook as well as heat water. So here, for example, now we will go to a methodology of the third concern for innovation, which is understanding all these insights. I already told you that we're working on this product, and I told you all the advantages of the product, but I need to take you through this direction of how we went about reaching this wonderful idea of the window mounted oven. The biggest challenge in the box type cooker was that it was large volume and you had to store it somewhere in the house. So people who had small houses had a lot of difficulty keeping it somewhere, and also the problem was that during rainy season it is not effective, so you need to store it somewhere on the top, and then there's a lot of resistance to bring it down and use it. So some of the key insights were, people prefer cooking from indoors, right? Placement and handling inconvenience had to be addressed. Existing cookers occupy a lot of space and difficult to store. Mirror needs to be moved every half an hour. So actually, if you want to be very efficient, you have to adjust the mirror really every minute. And outdoor cooking isn't completely hygienic. In this case, I can say that the parabolic one is not hygienic, but if you put a lid on it, that also can get hygienic. But for example, cooking rotis and all in the outdoor may not be very good for the parabolic mirror. Now, we have got a very good differentiation in the product. You have a lot of these high-rise buildings in the cities and they have no option to use a solar oven. But our solar oven gives you an option to use it in the balcony or to use it in the windows of your house. So that's a very big segment of users who can use the oven effectively. So you can see that the balconies could get the heat. Geographically, we are placed on the equatorial sun belt, and that's a real advantage, and we got enough temperature in our country. So students, we went on one of the surveys in Jodhpur, and we found out that our solar oven could actually compete with a gas stove to cook rice around half a kilo. The same time, you spend 45 minutes on the gas, and you can, same 45 minutes, we were able to cook rice, and the outside temperature was 48 degrees that day. Even at 46, it's possible to do that. So now we can say that we can really match the gas stove's heat, and that's the beauty of our country, that we have so much heat available in most of our belts, and that's the map to see. The fourth concern of innovation is the check. We can all have some great ideas, but how can we take these ideas forward if you don't have the right direction? So here, for example, we came up with the checklist for ourselves, that we said we need to make it convenient to use location-wise. We should make it easy to maintain, and it should be, hygienic. It should cook for at least 4 people in a family. See, students, you should realize that a brief has to be very critical. If I just say convenient for use, it can have multiple conveniences, right? Door opening, door closing. But we are saying convenience from location. Where do you keep it? So each of the brief points have to be qualified when you do a design brief. So here we have that type of qualification coming in. Should cook for 4 members at least. So I now know what type of size I should go for, right? And then should cost less than 3,000 rupees, remember? We were talking about our box type, which is 4,000 to 4,500. We are saying it should cost around 3,000, and it should match the aesthetics of the kitchen. So that's very interesting. Being design students, we're always looking at perception, visual perception, aesthetics, semantics. So my product should not look like a box. It should look like one more microwave or one more kitchen appliance, so that there's less resistance to use such a product. And once I get that type of acclimatization, maybe I'll be able to, pick up, very interesting situations. And hence we now look at ideas. So this is the most critical phase of a design student. Most of our design students like to build multiple ideas. They want to come up with a lot of creative ideas initially, and we also let them dream and come up with a lot of sketches. So here Avinash, of course, started with the box type oven, relooked at those sketches and said, what can I improve in this? Can I make it lightweight? Can I remove the mirror and put a plastic sort of barrier? So multiple ideas were thought of, and how I can improve the efficiency more by getting much better reflection of the sun onto the boxes. So all that, of course, he started with. Then he started with looking at vacuum tubes. Remember I was telling you, we have these water heaters which uses vacuum tubes, and in those tubes, because of the type of coating, the cooking happens very fast. He said, can I use some of those tubes over here? So he picked up a water heater tube and put some food inside, and it was cooking like nobody's business. And we also have such a product in the market called the GoSun. So these products can roast chicken faster than the gas stove and faster than the roasting electrical roasters. So now see how technology can lead to very convenient and very good solutions. So then, of course, he looked at circulating fans for circulating the heat. And another very interesting insight was that most of the heat was coming because of convection inside. So, he also looked at how we can look at, the circulation, how the airflow will happen, the hot airflow will happen, so that our food can cook faster. And then came his, breakthrough idea. He looked at a round, jar, saying that a round jar, the sun rays can come from all sides, right? Even if it's evening sun, it will enter, the mid sun will enter, and the morning sun will enter. So that's all his idea was, to now have a round shape, and that's the breakthrough idea he had. And from here, he said, wow, this is great.
So considering Mumbai on a summer day, how much temperature does it need, and how long will it take to cook?
Oh, that's a good question. In fact, I was sort of living on cooking my rice every day in a solar oven, the one we made prototype for 6 months. And in the summer, in the Bombay summer, it takes 4 hours to cook. And the temperature goes to 98 degrees for a very short time of around 45 minutes to 50 minutes. That's the challenge. So I said, if we can improve this oven for Bombay, it is good for everybody, right? So that's the whole challenge we learned, and we took this forward. So now we come down to the 6th concern of innovation. Whenever we crafted, I've noticed that students always built much better ideas. The creativity jumps multiple levels. And in this case also, Avinash picked up whatever is available around in IIT to start building his mock-ups as well as working rigs. What's interesting is here you can see Avinash picked up this acrylic sheets, and he built one enclosure. Then he also picked up the bottle, which is the regular PET bottles, and he put two of them together, and he saw very good temperature rise. So he had two walls. So look at the whole idea of conception. So he started with creating two walls. In between the two walls, you have insulation, right? Air insulation. So that's how he started, and he was very, very happy that he could get very, very good temperatures of 78 to 80 degrees already. So then from here, actually, we noticed that the temperature remained stagnant, and at 70 degrees, you can't cook. You need a temperature of 90 above to cook. So that's the reason why we went back to multiple ideas. He again copied the box type solar oven to see whether I put a glass on top, a double wall glass, and put the jar inside. Is the cooking better? And he noticed that this mock-up was really working very well. And then we got this bright idea to use the Bisleri large water cans. The large water cans are made up of polycarbonate. We didn't know that polycarbonate has this great property of letting the heat go in and not letting the heat come out because of its basic inherent property of insulation. So here, this was a great learning for us, and that came accidentally. So it was not part of design. We just saw those Bisleri bottles and we did, and we found the temperatures rising phenomenally in this. So it reached 82 degrees within 20 minutes in Bombay. Right, so that was a great lead for us, and they said, wow, this is the in thing to do. Most of the time when you do crafting, you get a lot of these type of wonderful ideas from things around you. And I've noticed this happening every time in all innovation projects. It's not that it's happened only here. So I would always encourage students in the engineering and design fields to keep on building mock-ups, keep on building prototypes of whatever available materials, and because those materials are around you, they may have some inherent properties which could be very advantageous. So in this case, this happened. And there, for example, now it was time for Avinash to go for his presentation in IDC, the final presentation, and he built this whole product now, which has a compartment in the middle, and he has the 4 containers so that your dal, rice, and one sabji, boiled sabji, can easily be cooked there, and then he had this round opening to the whole design. So this is Avinash's final model. All design students build models. A model is a mock-up. It doesn't work. Yeah, you have some question, Deepak?
Sir, if we put, is there any difference when we put one container and 4 containers?
Oh, very good question again. When you have 4 containers, your heat is distributed, right? It will take more time. It will take 4 times more time. There's no difference. But only thing is you don't have to keep on being attentive. And you don't know when the sun will go away. So you load your solar oven, and you can get all the food out in 2 hours or 3 hours, depending upon where you are in the country. So here, for example, Avinash built this mock-up model with transparent polyester sheets. Remember this file material, polyester, which is used for files? They're not at all good for solar cooking, but they are transparent. So what is Avinash showing here? In a mock-up model, you only show transparency because it's originally supposed to be polycarbonate, right? And it's very difficult to build polycarbonate. So he built with transparent sheets. He also fabricated the front cover made out of polystyrene, and he painted it. And look at this wonderful wheel. He created this wheel to decide how much speed you need to cook. You want rice, if you have loaded your cooker at 12 o'clock and you have to come in the evening and want to have hot rice, you can turn it so that a small amount of hot air will keep leaking. So the cooking will happen slow. And slow cooking is very beneficial for health and nutrition. So it can work as a slow cooker also. And this mock-up model then was presented to the jury members, and everybody was very happy, and Avinash, of course, passed with very good grades, and he then went and joined a company outside. And we are very happy to mention that he joined a solar company which does solar instruments for school education in Delhi. So Avinash made multiple, renderings of how the product will look like, how the product will feel, and he also actually, made a stand for it to be, shown to the presenters in his jury. And in this particular case, we have realized that when Avinash came to me for discussion, we said, Avinash, this is like, looking like, something else. It is not looking like your regular appliance, which is like a microwave oven or a fridge. So what do we do with it? So Avinash came up with this wonderful idea of having the front, like a square, and the door opening like a rectangle, and then you have the round barrier at the back. So it has the front which matches with your window, and the back which is a jar. So here, once Avinash left IDC, we continued the project. Thanks to the Ministry of Education, they gave us this wonderful project called the National Initiative for Design Innovation. Under this project, we could actually hire professionals from industry to take student projects to market. So in this case, we actually went to people who are very experienced from retired from Godrej, who came and joined the project. We had a design engineer who came from Delhi to work with us. With multiple team members, we started working on this product. We also brought in some expert CAD modeling person so that we could actually do the prototyping of the product. So in the prototyping, we actually built the window, the box which will fit in the window, in sheet metal, and of course got it, powder coated. And the back frame where the glass jar would sit was actually designed in such a way that you could place the glass jar into this wooden frame. So after Avinash made these wonderful, rectangular shape design, he also told me, can we make it look futuristic? Because it's a new product and people would like to see futuristic designs. So Avinash made a lot of renderings of how this product can be really, shaped innovatively, how the hinges can work, how the back will look, and how the front will look, and how the front door will open so that, you can cook very effectively inside. And he also looked at how can I make the, door at an incline, because you're tall and it's window mounted, so you could be able to see inside effectively. Here we can see that he's used, rather than a round hatch, he used a rectangular hatch also. So both the options he built, the round hatch was looking very futuristic, and the rectangular hatch also was futuristic because of the type of rendering he did. He used a lot of glass in the front, so that gave a lot of shine and the futuristic look to the oven. So finally, when we started working with this collaborative team of experts from industry and our own professors at IIT Bombay, different professors from IIT Bombay, from the Energy Science Department, we had Professor Kedare. From the Energy Science, again, we had Professor Modi, who would actually guide us on the thermal analysis part of it. We had professors from Material Science who were guiding us on the coatings which would come on the on the utensils as well as the black body. We had professors from the polymer science from IIT Delhi who are guiding us on the polycarbonate rheology. What type of polycarbonate surface should be available? What type of plastic material should be used effectively for such an application was also studied very effectively. And then of course we had design where we were looking at how the whole thing can be put together to make a very effective design. So here we went ahead with our prototyping, and the first challenge was that we had to create this double-walled glass jar. Remember, we knew it was polycarbonate, but Avinash left, right? When Avinash left, we said, who will make polycarbonate which is so difficult to mold and make, whereas these scientific instrument companies already make jars. So we went to Gujarat, to one of the largest glass companies, and we made this double-walled vacuum jar. We said if it is vacuum, it will be much more effectively insulated. So we created the vacuum jar, and with this vacuum jar, we said we won our battle, and then we could cook cake. But the challenge was the glass was very thick. It itself was taking away all the heat. Remember I was mentioning the glass is not as insulated as a polycarbonate. Polycarbonate will take the heat in and not let any heat go out, whereas the glass jar will take the heat in, absorb the heat in the walls of the glass, and hence it was not very efficient in the Bombay weather. Bombay we could not cook. Then we had to take it to a place where there is enough sun like Nagpur, and then we tried out that it is working well. But then we all know that our cooker should work in the worst conditions, which is Bombay. So we again said, let us relook at it in a new way of how we can make this cooker more effective. So once we noticed that this window mounted metal body and the glass mounted on this metal body was not very efficient in Bombay. We could not cook even once in this. That is, nothing cooked in the Bombay weather, but we could make cakes in Nagpur. So with this challenge, we said, let us redesign the product to make it more effective to work in the Bombay weather. So that will also help us to make better product. So if it works in Bombay, in any of the other places where the heat is high, it will really work very, very well. We brought in more team members into our project. We are nearly, like 2 more engineers who joined from outside. Then we did a brainstorming session and we created multiple products. We said, let us just test the basic principle. So we created this polycarbonate box. We call it the working rig. And then we put it in the sun. And to our great surprise, it was working beautifully. The temperature went to as high as 108 and we couldn't believe ourselves. The transparency was great. The product was perfect. And then, the temperatures were very good. 108 is really good. And then we had multiple discussions in the studio of how to productize this product. And then, we also said, if you have to productize it, can I use double-walled glazed sheet, which is very commonly available in the market? And then we used this sheet, it was not working. The temperatures didn't go up. So it's interesting that our transparency and the amount of sun which goes inside is very, very critical for our oven design. So now we had this wonderful task of building a prototype which will also be desirable, which will look good, which will be, which will look nice on your window and also work well. So then we went back to, remember, I was always mentioning that design is an iterative process. We went back to our drawing boards, which is we went back to conception, created a new design and actually fabricated this new design in the studio by laser cutting polycarbonate sheets. You can see our wonderful model maker over here, Kini. He's been a veteran in model making and he actually painstakingly stuck all the laser cut polycarbonate sheets together to build this first prototype. I should call it the second prototype because the first prototype we failed, right? We made the glass jar and the metal body. That was the first prototype. Then we made a working rig. Remember, I was mentioning the working rig, which was a rectangular box with a door. And this happens to be the first prototype which we built. So while we were building this model, we got this wonderful opportunity to present this innovation at Rashtrapati Bhavan in New Delhi. Professor Anil Gupta organizes this annual event of innovations which are in the country at the Rashtrapati Bhavan, and the president actually visits and sees all these innovations. So we took this sort of product there, and hence we created this artificial wall, and we created this window, and then we took this whole product by truck to Delhi and exhibited our first prototype in the exhibition, and we got a lot of laurels. So after coming back from Rashtrapati Bhavan, we again went back to our thought process of how can we now make the product go into the pilot production. Remember, we crossed the first valley of death, which was the mock-up to prototype. Now from prototype, we need to cross the second valley to reach the pilot production and then see how the things go. So we want to look at new forms, we want to refine the design, and we also want to work for ease of manufacturing, because ease of manufacturing will give you better cost-effective design. So here you can see how the whole ideas were started building up, the shapes were considered. It's very interesting that this is a very important here, that we can't have any undulations on the top. If you have undulations, dust will collect over there. It had to be smooth, right? And on top of it, it can't have any crevices which will actually put shadow of the polycarbonate on the product. So you can't have any shadow. So no shadow, no steps. So that is the whole design requirement. So you see that design is dictated by the form where there is no shadow. So I'm extremely glad to mention that after spending a couple of years in industry, we could actually, convince Avinash to join back with us. And Avinash started this whole, form generation assignment again, where we're very happy that we could generate a lot of interesting shapes. And with now new experience, Avinash had with the instrumentation company in the solar, field, he was, better armed to look at shapes in a very, very effective way. And you can see how Avinash and Aniket, who is our CAD modeler, both built this multiple options. And we were weighing the pros and cons of each form in this, and we could see, what we could do. And we then narrowed down to 5 of them, and, finally selected the one which was the most sort of effective from a solar point of view. At the same time, it also gives you very good appeal from outside. So these are small 3D printed models, what you see over here. So after these 3D printed models, we were more sure about this shape. And once we were sure about the shape, we then spent, some of the finances from the Design Innovation Center to build the tools to do vacuum forming. Vacuum forming is a process where you can create large sheets. But now remember, we had the whole round glass in one shape. Now in vacuum forming, I need to make it in 2 parts. So we built the product in 2 parts. So we had 4 parts just for the shell, and then we had the door and the frame. So this is the the pilot production where we created 20 solar ovens using the vacuum forming method of polycarbonate sheet. We created around 7 to 8 varieties of trays. Remember, it's very interesting that without the tray, the solar oven doesn't work. The tray is the one which takes all the heat and transfers the heat to the cooking vessel. So this tray is actually the most important component. So here we found out what materials will work better. We found out that aluminium is the best material for this. Of course, copper will be better, but it's very expensive. So we used aluminium, and the coating, the black coating also is as important as the material. So we're very happy that the coating came from the National Environmental Engineering Research Institute. The professor over there built this coating and she's patented it. So we're going to use this coating, and it increases the efficiency from 5 to 7%. So which is fabulous again. We actually tried out different type of trays, and we then narrowed down on the flat tray without any holes, because the convection currents are moving from the bottom to the top. Here we had a lot of inputs coming from our Department of Energy Science, as I told you, Mr. Professor Kedare and Professor Modi. Then we also looked at the containers. We brought standard stainless steel containers, and we found out that the stainless steel containers are not good at all. Even that value of aluminium, which is the conductivity, which is so important here, that it took nearly 30 to 40% more time to cook in a stainless steel container. So we went back to aluminium containers, and we had to work on multiple challenges. How will we transport such a oven? How will we install it in people's houses, right? It has to be installed in the right wall of the house, because the wall has to get sun and the window has to get sun. You can also make a hole in the wall and fit it, of course, and then it's safe because polycarbonate is very strong. You can always fit from inside, and nobody can break it and come in. And how will the households receive it? Will the household like it? And where will they buy it from? Who will manufacture it? What material will you use? So multiple issues, material you'll use for the doors and things like that. Multiple angles were there. And here, for example, again, we were very fortunate to have our collaborative professors visiting us in the studio, working collaboratively with us to understand all the various aspects. And we actually worked on the thermal analysis. We brought an expert who works on aircraft engines to work on the thermal circulation inside the oven, and then that actually helped us to validate the concepts beforehand. What type of size, what type of thickness of the polycarbonate, what type of gaps between the polycarbonate, all that became very, very critical. And another important issue was we had to also understand the flexibility in changing the dimension, what type of volume should it have, and we also had to look at recreating the environment at different locations, different angles, how will it work, and of course we also had to look at the saving of cost, from point of view of from the prototype to pilot production, and then we need to also relook at manufacturing so that we can save the cost very, very effectively. So with
Hello sir, yes, this like after all the consideration, like how much efficiency can I consider for our prototype, final prototype?
So actually efficiency is a very difficult question. We are always benchmarking with the box type cooker. The box type cooker is actually a very, very efficient cooker. It's got a mirror, right, for reflection, whereas I'm not even using a mirror. So so our plan was to at least reach the box type cooker levels of efficiency, but we were in this case, as of now, with this pilot production, we were around 85% as efficient as the box type. So then we said, oh, can I put a reflector on this and check? So we added a reflector on the oven, and when we added the reflector, our efficiency jumped. We were better than the box type. But we were not happy. We said we don't want to add a reflector. We want to make this a non-reflector based oven. So in this case, we went to this wonderful, food exhibition in Ahmedabad, and a lot of people in Ahmedabad use solar ovens, and they kept on asking us, you give this oven because it doesn't have a mirror. We have a lot of monkeys. The monkeys break the mirror, and we're not able to use a solar oven. So this is a great opportunity for us for places because there is no damage to the solar oven. So here, for example, so just to answer your question in one sentence, at this particular stage of our project, we reached an efficiency of 85%, and then we were struggling to go forward. And then the thermal analysis helped us phenomenally to see how we could actually use the dimensions more accurately. We realized that the volume of the air inside was the most critical one. And then these analyses helped us that we need to now, for our next design, we'll have to reduce the total volume and keep the volume as low as possible, only as much as my boxes which are going to cook. So that is a great learning for us. Okay, we were very fortunate that we had 4 wonderful interns from TERI. We did a lot of analysis of adding insulation between the polycarbonate panels, and the TERI students came and said, so it's not needed, your temperatures are as low as 100 degrees, and for 100 degrees temperature, your air insulation is good enough. See, you can't even increase your cost, right? So that's a wonderful inputs from them. They did a lot of analysis. They also took our oven to Jodhpur to try how the oven will cook, and we're very fortunate that we got very good results in the locations in Jodhpur, and they all came back with different options of the foam one, the non-foam one, and the reduced volume one. And finally we reduced the volume, and then by the time the TERI interns were working with us, we were very fortunate that 4 interns from the Dadar Catering College approached us and said, we want to work on a project with you. And these interns were so fabulous that they would come up with recipes for our solar oven. So we created various recipes for solar oven. So they would actually look at the temperature. They would say, okay, we can cook this, we can make pasta, we can make these type of cakes. And they also made a cookbook for us. And with these type of inputs, our project became really very, very exciting for all of us to take things forward. The material thickness plays a very, very vital role in this. The polycarbonate is a very, very expensive material. Here the outer and the inner shell, the wall thickness will have to be as low as possible. At the same time, the wall has to be thick enough so that it doesn't break, right? It's an outdoor thing, so it has to also have good volume. And then, for example, the next important thing is the aluminium. What type of thickness we will use in the aluminium plate? So that is also a very, very critical thing. So the more the thickness of the aluminium plate, there is an efficiency model. At what thickness will my food cook better? So we did those trials, and we finally settled down at 2 millimeter thick aluminium plate, which will be coated with this special coating from our professor. And then of course the utensils were all made up of aluminium, but we can also use ceramic coating for the aluminium so that it is also safe for consumption, because aluminium with oil people are not preferring nowadays because of the temperature. But we are not doing oil frying in this aluminium, so it's still very hygienic. But at the same time, there's a perception in people about thickness. So volume to surface area became very, very critical for us, and we had to really then look at look at the volume very closely. So here, for example, we have the solar, window-mounted solar oven, which will save our gas, because the cooking in the Indian households, a lot of cooking is actually boiling, and later on we add all the other processes like tadka and like seasoning, which is done later on. So here, if the cooking can happen in the oven, and then you do your post-processing in the kitchen on the regular gas stove, you'll be saving nearly 80% of your gas stove. If you look at the cost of the gas, for example, if the cost of the gas cylinder is around 700 rupees, you'll be able to retrieve the cost of 700 rupees by 200 hours of cooking. And this 200 hours of cooking can happen in as short as, say, 100 days or 3 months. So it's a great opportunity for us to save gas and use solar oven, and you'll be saving money too. But it's not just saving money. It's a great possibility that your food which get cooked in the solar oven preserves nutrition, because it's slow cooking, and in slow cooking the nutrition is preserved, the food is actually tasty, and of course you get the fuel for free. So with these type of things, we actually did multiple tests with various locations. We went to the food festival in Ahmedabad, and in the food festival we got some very, very good results, where the people were also giving us very good ideas of recipes. And to the everlasting credit of a businessman in Surat, he came to me and said, "Professor Chakravarti, what is this product?" I told him this product is a solar oven. It can cook everything. He said, "You professors don't know business. If you sell it as a rice cooker, I will sell 1,000 in 1 month. Why do you want to sell as all cookers, right? You're cooking predominantly rice and dal, right? You sell it as a rice cooker, then people will buy it without any question, right?" So that's very interesting. How do you focus on the customer discovery and then start building? So that's what we called it. Then Avinash came back and called our oven Sunrise. He branded it as Sunrise. We didn't stick to that name, but that's how we went forward. So now in this stage, you can see in the pitfalls of innovation. Now this particular this particular design is at our first pilot production level, and we also know now that our air volume was large. So we had to make it more efficient. So we went to multiple small-scale manufacturers to see how we can build our pilot production. And this is one of our, like Macwell, which is actually working with us to suggest. They also told us how much the cost of molding would be, what about investments we need to do. And with all these inputs, we went ahead with our pilot. In the meanwhile, Avinash started building his CAD models so that we could actually injection mold this product. And after these CAD models, we came up with multiple sort of design interventions. How will the branding come? What type of place we'll put the brand at the back? And how will the product work on a stand, which is also very critical. And and how will it look on the window of a house? So with all these inputs, we went ahead with the patenting process. It's very interesting that when we went for patenting, first we had to get a patent for our country. And after we got the patent for the country, the patent attorney asked us, do we want to get patent worldwide? So when we looked at the worldwide patent, it was very, very expensive all across the world. We did the patent in some countries which had ample sunlight, like Australia, USA, and South Africa. We didn't patent all across the world because it was very expensive to do patent across the world. So here, for example, we created some impressions of how these products will look on the building. And
Sir, how will it affect it's in straight vertical line?
That's a very, very good question. But out of the total available daytime, most probably exactly getting a straight line and sun on top of that particular line would be very little time, maybe 10-15 minutes at the most, in a very rare situation. So hence it really doesn't matter if all the ovens are on the same side or on the same straight line, because our cooking time is very long. It is 1.5 hours or 1 hour. So for that type of length, it really doesn't matter if it is there. But of course, it's a very good question. We can always stagger it. Each flat can have little bit of staggering of the oven, so that even that one shadow will not happen. So this is the final specification sheet for our product. We have the outer shell in polycarbonate, which will be injection molded. The inner shell also will be made out of polycarbonate, and polycarbonate is a very, very strong material. Then we have the, like the main, metal frame, which will be around the oven, made out of, mild steel powder coated. The door can be in ABS, the outside shell, but the inside part of the door will be in polycarbonate, and the outside the shell we want to use glass if possible, because it's very nice for the graphics. And the tray of course is aluminium sheet, and the food containers are aluminium with the specially coated of black, which actually improves the absorption of heat. So after this whole study, we actually sort of reduced the volume of the oven and actually built our refined models. And in the refined models, the volume was reduced, and with that reduced volume, we did the testing, and we are very, very happy that we got at least 5 to 10 degrees of increase in temperature and efficiency of around 5% more. So with that pilot, we finished the testing, and then we again went into the tooling process. So it's the second pilot production we built, and after the second pilot production, we could really achieve very good results. Our temperatures, in Bombay reached around 98 degrees, and we just coming out of testing on our terrace in IDC, and I'm extremely glad to show you the product. So we created the second pilot, and when we did the first pilot, we came up with some interesting insights. While people were using, the users came back and said, we are very, very happy to dry pulses, to dry jeera, to dry pepper. So it also became a household dryer. When we are not using the oven for cooking, you can use it for a household dryer. So after this, when we built our second pilot production of 20 numbers, we created the multiple toolings in aluminium. The cost of pilot production also went up, because we want much better tools to have much better finish. But we still kept the tools, for vacuum forming. We did those tools, and then we created the next design, which is the much more slimmer and a smaller solar oven. In this solar oven, what is very interesting is we found out that the oven is not being used for cooking, and when it is not being used for drying, you can use it to heat your room. That's a great insight we got when we installed one of our ovens on the terrace and created a wooden box around it, and we noticed that the temperature inside the wooden box had gone up by 8 degrees. So just imagine in Delhi, when the temperatures outside are low and the sun just comes out, you can actually use the oven, will start heating your house. And we are very, very bullish about that aspect of the solar oven. Most probably the people would, some people may just buy it to heat your house, because it's the most comfortable way of heating. Even if you're not in the house, your house is getting heated. So that's the whole beauty of all the three options. So now we have a solar oven, we have a solar dryer, and we have a solar room heater, all into one. And that will be a great formula, because the tooling cost is going to be high. When the tooling cost is going to be high, our product cost is going to come down, and we are going to hit a product cost of around 4,200 rupees. We also are very, very glad to mention that one of the largest manufacturers who build prototypes for large companies like Crompton Greaves has come forward to do the tooling for the product. And then we are also very happy to mention that Prestige, which sells kitchen appliances and kitchen utensils, is ready to market the product. There are dies which are made in special purpose materials and manufacturing, and these dies could go as high as 40 to 80 lakhs. And then if we don't have large volume production, our product cost will not come down. So to keep the product cost around 4,200 rupees, we will have to really have large volume of sale of the product. So with this, I would like to quickly demonstrate all the three aspects of the product to you. First, let me show you the function of the solar cooking, which now the new pilot has a door which actually drops down, because now the volume has reduced, right? The volume has become smaller, and hence the door is no longer opening like this, like our first pilot production. It drops down, and actually you have the tray which is inside, and you have the sort of container with the black coating where you can cook your food. You also notice that we increase the size from our earlier design. The more the black material inside, the aluminum inside, the production is actually much better. So here now this is our solar cooking. You have the you have to buckle your, the insulation is a very important aspect. The door has to be tightly buckled. You actually buckle the door and then the cooking happens. So when you're doing the drying, you will need a separate tray for drying. This can be larger or smaller. So you add the drying tray, add your fruits or vegetables or jeera on this. And if you're using jeera and pulses, you can always use this with an open lid. When you're drying, you don't close the lid, you keep the lid open, and or you can use for vegetable drying, you can use the tray. And the most important is when you're drying, you don't close the door fully. You actually buckle only a small part, and you have this gap of 5 millimeters here, because of which the hot air would actually escape here slowly, and your drying happens, and the humid air will escape from the top. So this is for the drying method. So now when you're doing your room heating, you actually remove your drying part, and then add the room heating product. This is a very interesting room heater container where it has a fan which is powered by a solar panel. So you have the sun coming in, and the solar panel will power the fan, and there is this very interesting heat sinks inside. So this whole product becomes hot. When this becomes hot, the air flows out. So you put this product inside, and actually you close and you don't need to close the door, but you can still close the door and keep it at the drying stage. So with that, you will be able to get hot air coming out from the inside. When the sun is very harsh, the fan will go fast because there's a solar panel. And when the sun is low, the fan will be low. So that way your room can get hot.
So regarding the installation of solar oven in the apartments, so each window is of different sizes, and how did you arrive at standard size?
What we did was that we created various buffer plates. So depending upon the window size, the installer will take buffer plates and add those plates like exactly the same way they add window mounted air conditioners. The air conditioner is the same size, but you have those plates which they put around the window mounted air conditioner so that you can block the whole window with that. So we use the same technique. And again, what we did was we went to a manufacturer, we went to Tata Sky people who install dish antennas on the roofs. And then it's very interesting that we went to their institute where they actually train them to install, because you have to get the right angle of the satellite. So similarly, we plan to go to people who do those installations, train the installers, so that when they go to the house, they put on the right window, and the product will be a success. And of course, the cost of installation also has to be adjusted in the cost. This becomes a very important aspect. When it is outdoor, you can always cook outdoors. You can cook in the balcony. There's very less requirements. And if it is the railing mounted, also there's an attachment. So all these attachments are available, so they can use it in different contexts.
Sir, are there any safety consideration while using the product for the first time user? Because since the product is reaching 100 degrees and much more.
Yeah, that's a very good question. Somehow we didn't think about it, because when I used the oven, the aluminum plate is very hot. It actually burned my hand once. So maybe the front, maybe we could, redesign the front so that we can hold the part which is coming out. Maybe this part can be little insulated, so that when I hold the tray to pull out, at least it's not, and then by the time I pull out the tray, maybe I'll be able to, sense the heat and, do that. Very good question. Actually, we didn't think about that much because so occupied, and we were always very happy to get more temperature. So we didn't think about it. But I think safety becomes a very critical thing. And we also are planning to have a temperature measuring device here. It actually shows you what temperature it is. But as you rightly said, when you open and when you think, it is not on the gas stove, it's not hot. So that's a very good point. I think we will consider that and add a little trim on this edge so that it will not scald anybody.
So what is its approximate cooking time, sir? Around 4 to 5 hours it will take?
The 4 to 5 hours cooking was there when we were making our first prototype. Now, for example, this will actually cook rice in around 1.5 hours of time if the outside temperature is around 36 degrees.
Oh, very easy to use then. It's-
Yeah. Because 4 hours is really long,
Yeah,
as you rightly know.
Yeah, very interesting.
Is there any extra maintenance that we need to take care about, like after buying?
Fabulous question, Ashuj. This is the biggest challenge for us, that we need to keep the top of our oven clean. And a lot of dust keeps coming in. So we now are mentioning that when it goes to be fitted in the window, we want a window on the top so that you can open that window and clean the top surface of the oven so there's always clean. So that is a very big challenge in this product. We also are thinking, what can we do to innovate? If you throw water on it, also it gets clean, but that needs to be really addressed very effectively. If I get a reflector on the top, that reflector, when you lift, it will keep the surface clean, which is still possible. We did make some trials, but we've still not gone. If you put a reflector, that what Advaita was talking about, that 1.5 hours will go down to 1 hour. It's really good. And the cost will go up by 500 rupees only. So it makes a lot of sense to use a reflector, but we were stuck on our mindset saying that, okay, we won't want to use a reflector. We want to use only the greenhouse effect of the oven to cook.
So how much time usually does the drying take in this?
The drying actually takes a lot of time. For example, if you're drying pepper, pepper seeds which get humidified, it will take around 4 to 5 hours. And you can't roast peanuts for even 4 days. So it's actually not a product which has very high temperatures, no? The temperatures are, around 100 degrees. So it's not very good for roasting, but drying it does, but it takes really 8 hours or so.
Sir, if that is a polycarbonate on the outside, if it is going through a lot of radiation outside, so won't that plastic fumes dissolve into the food or a drying thing that we place inside?
Vivin, you know what is baby feeding bottles made of?
It's plastics.
Polycarbonate plastic.
Yeah.
So polycarbonate is an engineering plastic. It's been engineered to be very, very good for sterilization. So you sterilize the baby feeding bottle in your houses. Hence, it has no fumes coming. But there's a very big challenge. This is always in the sun. So the plastic can get deteriorated by UV radiation of the sun. So it can become yellow. So we are now going, remember I was telling you about this polymer science professor in IIT Delhi who is helping us to work on the rheology of this to add UV stabilizers so that the product doesn't become yellow. Because if it becomes yellow, it will stop cooking.
Yes. Thank you, sir.
Sir, about the heater function, even if it's not in the heater mode, will the room get heated? Is there a warming effect? Like even if it's cooking, will the kitchen get heated as a byproduct of that? Like, have you tested it out or?
So that's again a fabulous question. When you're cooking, the heat is of course there, right? But I'm not using any your hot food will be as hot as any of your kitchen appliances. Whatever you cook, your gas stove, if you cook cooker, if you have a pressure cooker on your gas stove, that will radiate some heat. It's the same type of radiation my oven will do. If you're not cooking anything and you keep it fully closed, right? The oven is just hot, it's not radiating anything outside. When I keep the oven half open like this, then only the air is getting hot. So you can choose not to use it by locking it fully, so your room is not getting hot. So you can choose to make your room hot whenever you want.